changing weather patterns are already affecting our industry. What we can expect in the years ahead. From the National Business Aviation Association, this is Flight Plan. I'm Rob Finfrock with your trusted source for business aviation news and information. Now, climate change, its causes, and its implications all remain touchy subjects in our industry and our world. But if you look around, it really can't be disputed that changes are taking place. Many parts of the Northern Hemisphere have experienced record high temperatures this summer, and wildfires continue to plague parts of the country. Out west, rivers and reservoirs are drying up from lack of significant rainfall. And it's having an effect on aviation as well, from dodging stronger convective activity driven by hotter temperatures to changes in the jet stream affecting flight times. But perhaps the greatest danger comes from clear air turbulence that, according to research by one of my guests today, led to 62 documented incidents on board aircraft flying over the U.S. in 2019. And those numbers will likely climb as both temperatures and flight activity increase. CAT occurs without warning and can cause severe injury, particularly at the back of the aircraft for passengers and especially flight attendants, who suffer nearly 80% of all serious injuries, including leg fractures, spinal trauma, and other maladies. Today, we'll examine these effects from changing weather patterns and what mitigations are available for our industry. We'll begin with Dr. Paul Williams, Professor of Atmospheric Science for the Department of Meteorology at the University of Reading in the United Kingdom. And Paul, it really does seem to me that weather patterns are shifting, especially with temperatures in the UK recently climbing above 38 Celsius or 100 degrees Fahrenheit.
I think you make an excellent point, Rob, that we've reached the stage now where no sane person can deny really that something is changing with the weather, that the climate basically is changing. I mean, in terms of turbulence and clear air turbulence, which is my special subject, well, that's generated by wind shear. In other words, changes in wind speed or direction from one part of the atmosphere to another. And of course, where's the strongest wind shear on the planet? Well, of course, it's in the jet streams. And so that's why there's a very strong link between the jet streams and clear air turbulence. Just to drill down into those details a little, I mean, you might wonder, why do we even have jet streams in the first place? And it's quite instructive to think about that. And it's because basically of the large temperature difference between the very warm tropical parts of the planet and the very cold polar regions. And there's a very profound law in meteorology, which we teach our students in week 1 at university. It's called thermal wind balance. And it basically says that whenever there's a horizontal temperature difference, there's going to be a wind shear in the perpendicular direction, to put it simply. So that north-south temperature difference is driving a vertical shear in the eastward wind. And that's what gives us the jet streams. But it's also what gives us clear air turbulence, because whenever there's a vertical wind shear, it means the different layers of the atmosphere are flowing over each other. There's a relative motion. And if that shear is strong enough, basically the atmosphere can't contain the shear anymore, and it becomes unstable, and little tiny irregularities in the flow grow exponentially and become chaotic and turbulent. And the end result of that process is clear air turbulence.
Also joining me today is Judith Reif, a contract flight attendant for JR Flight Services and chair of the Weather Subcommittee to the NBAA Access Committee. She also holds a bachelor's degree in environmental science, including meteorology, from Western Kentucky University. And Judy, between your job and your educational background, you're really on the front lines of the situation. But have you and your passengers noticed any changes while flying?
I've seen a change in the flight environment probably over the past maybe 3 to 5 years. In my flights, per se, I've seen it become more turbulent in certain cases. I've seen clear air turbulence. I've seen mountain waves, all kind of normal when flying in an aircraft at altitudes for us above 35,000 feet. But I've definitely seen an increase. As far as the passengers, maybe they have noticed additional or increases in the turbulence, but nobody has really remarked about it.
Good to know that your passengers are taking it in stride so far. But just fairly recently, I noticed posts on social media from several of my friends who flew to Oshkosh, Wisconsin at the end of July, commenting how their trips to and from AirVenture were particularly bumpy. A couple of them even posted it was the worst turbulence they could remember. Now, that's well under the flight levels, say within 5,000 and 6,000 feet AGL.
The other day, I was coming into an airport in East Texas, and we were in that boundary layer, about 3,000 to 5,000 feet, and we had pretty bad turbulence. It was probably because of the heat of the day, kind of the little thermal levels coming up and down there, but it was pretty rough, and that's the roughest I've seen in a long time at that altitude.
So it's bumpy up high and bumpy down low. Are we talking about the same phenomena, Paul?
As meteorologists and atmospheric scientists, we divide the atmosphere up, and the layer nearest the ground is called the boundary layer, and there's a lot of turbulence in there, but it's not what we would strictly categorize as clear air turbulence. Even if it occurs in clear air, it doesn't meet the strict definition, because we're really talking about, with CAT, talking about turbulence in what we call the free atmosphere above the boundary layer, 30, 40, 45,000 feet. That's true CAT.
I see, but can these examples be tied to other weather pattern changes we're seeing?
Absolutely. I mean, we're putting more turbulent energy into the atmosphere by heating it up. And I mean, so the interesting point with clear air turbulence is that the planet is not warming uniformly. And if we're up there at 35, 40,000 feet, actually the tropics are warming faster than the poles, oddly enough. And we know why. It's because as climate change warms the tropical air, it can hold more moisture. And that means that more heat gets released as the warm air rises. So there's a little feedback going on there. But the tropics are warming faster than the poles. And that means that the temperature difference between north and south, which is what drives the wind shear, that temperature difference is getting stronger, basically because of climate change, and that means more CAT. And we clearly see this in observations. We published a study recently showing that the jet stream has already become 15% more sheared since satellites began observing it back in the late 1970s, and we expect a further 20 or 30% increase in the shear in the jet stream by the end of this century. Now, what that equates to in terms of CAT, according to the studies that we've published, is maybe 2 or 3 times as much severe CAT in future. So really not good news for nervous flyers.
More of our conversation in just a moment. But first, this message from NBAA.
NBAA Flight Plan listeners, are you getting recognized for your leadership? NBAA now offers certificates and other credentials in safety, sustainability, and more. Visit NBAA.org to apply today.
We're back now with Dr. Paul Williams and Judy Reef, and our discussion about long-term weather changes and their implications to aviation. I'd also like to welcome in now John Kosak, CAM, Program Manager for Weather with NBAA Air Traffic Services and the association's liaison to the NBAA Weather Subcommittee. John, you've heard Judy and Paul talking about the changes we're seeing in the flight environment due to shifting weather patterns. I can imagine it's also been a challenge for the specialists at the FAA Air Traffic Control System Command Center, coordinating flights in our national airspace system.
I think you hit the nail on the head with your, talking to some of your friends flying back and forth to Oshkosh. No one likes turbulence. They don't like flying in it, and they really don't like holding in it. So here at the command center, if they see large SIGMETs for turbulence, they're likely to actually issue required routes to move traffic out of those areas. Centers and TRACONs may move flight tactically away from smaller areas of reported turbulence, which of course brings me to one of the topics that I'm most passionate about, PIREPs. If you fly into or through an area of turbulence, please submit a PIREP. It helps those other crews currently in the vicinity, schedulers and dispatchers in the planning stages, ATC as previously mentioned, and of course the meteorologists trying to get better data into their models for more accurate forecasts. Speaking of forecast accuracy, if you fly through an area of forecast or previously reported turbulence, but you don't experience it, the null PIREPs are just as important.
Obviously, there's nothing more valuable than that on-scene report. Paul, you recently presented a panel about the effects of climate change on aviation during an FAA forum examining turbulence and how to mitigate its effects. Looking to the future a bit, how do you see the flight environment evolving over the next, say, 10 years? And what can we do to adapt?
I think there are things we can do. John mentioned, just simple sharing of information via PIREPs, or in fact, there's now an automated system that's been set up by IATA, the International Air Transport Association, called Turbulence Aware, which is real-time sharing of automated turbulence data. So that's great. I think it would be great to improve those turbulence forecasts as well. Some of the best algorithms in the world are right over there in the US, coming out of NCAR, the National Center for Atmospheric Research. But there's always room, as with ordinary weather forecasts, they're not perfect. We'd like to make them as skillful as possible. And if we could get them up to 90 or 95% accurate, then no one really should be encountering unexpected turbulence. There's also technological developments that could come online as well. The conventional radar on board cannot detect clear air turbulence, but there's a technology called LiDAR, which potentially can, and it operates on the same principle, but it uses ultraviolet laser light, and it can detect little invisible density perturbations ahead of the aircraft, 10 to 15 kilometers ahead, according to some test flight results I've seen. So there's promise there. Unfortunately, this LiDAR technology is very expensive. It's very heavy as well. It's a big, heavy box. So the business case for retrofitting a fleet of aircraft with LiDAR is currently negative, but that might change in future. There are other problems as well. It does involve shining a high power laser out of the front of the aircraft, which isn't necessarily ideal. Especially if that some stray laser light accidentally enters the cockpit or a passenger window of another aircraft. So there are some problems there that we need to overcome. But if this LiDAR technology miniaturizes and becomes less expensive, I think we might see in a few decades' time, certainly if turbulence increases as I expect it to, we might see the business case for retrofitting a fleet of aircraft with LiDAR become, flip into a positive business case, and we might see it rolled out. So we'll see what happens.
So it sounds like the focus is on improving detection of clear air turbulence and adapting to this environment more than acting upon it.
Yes, I think so. And there are other things that come into the equation too, like I'm not an aircraft design engineer, but from talking to people who are, I understand that more modern aircraft have a better dynamic response to turbulence. I think the wings have more flex in them, and so they can absorb some of the turbulence with the main part of the aircraft not bouncing up and down as much as perhaps an older airframe would. So I think we need to push forward on technological forecasting, engineering advances. I think all of these things will help us to minimize turbulence encounters in the future.
Judy, what advice do you have for how flight planners and particularly flight crews in both the front and the back of the aircraft can adapt to this environment and mitigate the effects from turbulence?
I'm going to tag on to what John said a couple moments ago, and even what Dr. Paul was saying about the aircraft, and we'll address the PIREPs. But for many of the newer aircraft out there, on the cockpit display unit, there is what we want to call the winds page that a lot of the pilots can pull up and view the winds. At a particular altitude, they can look at the velocity of the winds, the direction of the winds. And if there's a directional change or speed, change in the velocity or within a short distance, there's likely to be turbulence in that area. A lot of the pilots will actually pull it up and look at the winds at a certain altitude and where we can expect some turbulence. So that resource is available to the pilots. Pirate reports are a great thing. I've been flying for 21 years, and in certain cases, I've seen a lot of pilots not provide feedback for a PIREP. I've been at moderate turbulence at about 40,000 feet, and the pilot did not relay a PIREP report to ATC. I felt it was important, but he chose not to do it. As far as preparation goes, there's so many great resources available. Aviationweather.gov is a great resource to look at the SIGMETs. Again, PIREP report. There's turbulence forecast. I personally look at the surface progs, and I also have a turbulence forecast app that I look at as well. So there's a lot of great resources available to schedulers, dispatchers, pilots. I know pilots use a lot of the new applications, for-flight applications, or any of the others that provide turbulence forecasting as well. So again, there's a lot of great resources out there that can be used for flight planning and possibly, if you can, avoid turbulence.
And it's important to avoid it if at all possible, as I know you've crunched the numbers on the consequences, Judy.
Turbulence injuries are huge within particularly the 121 world, but it happens in the Part 91, 135 world as well. So far this year in 2022, there's been at least 7 Part 91, 135 corporate aviation turbulence events. One was in Odessa, Texas. They encountered moderate to severe turbulence on approach, which did injure 6 passengers, one with a broken neck. And then last year in 2021, there were 7 corporate aviation turbulence events. 3 of them were severe with passenger injuries, and one included a Part 91 Subpart K flight as well. So turbulence injuries are happening. I think what we as flight crew need to be more mindful of is just better communication between the flight deck and the cabin crew. I'm a big advocate of maybe around the top of descent, having the pilots and the flight attendants use their best judgment, but seatbelt sign on. Again, like I said, use the best judgment. You might not have to have the seatbelt sign on at top of descent, but at least about 20,000 feet and on descent, because most of those injuries are happening below 20,000 feet.
Paul, we focused a lot on turbulence in this discussion, and for good reason. But what other conditions and changes might we see in the future if temperatures continue to climb higher?
Yeah, there are many possible things I could throw on the table here. Climate change could affect aviation in many ways. Some of them may be beneficial, some of them may not. Certainly the jet streams moving, and we have evidence that they are slowly moving in latitude, will impact flight routes, and that could have consequences. I was talking to some people at NATS, the air navigation service provider in the UK, about, if flights are coming in more to the north, if the jet stream moves a little bit north, then that has implications for air traffic controller load and how many air traffic controllers are needed up in Scotland compared to down in England. There are other impacts too. The possibility of increased flooding of coastal airports on the ground, caused by rising sea levels and storm surges. I'm sure we all remember LaGuardia being closed for, I think it was 3 days after being hit by the remnants of Hurricane Sandy back in 2012. Both the runways were underwater. And according to a recent study, Sandy-like flooding of New York City is expected to occur a lot more frequently in future, maybe once every 5 years in just a few decades' time. That would be catastrophic for airports like LaGuardia, which is just a few feet above sea level. And we also know that the sea level rise from just 2 degrees Celsius of global warming would put 100 airports around the world below sea level. There are other possibilities too. Takeoff weight restrictions I could mention, because as the air warms, it expands and it becomes less dense and thinner. And that means that there's less atmospheric mass available to lift a departing aircraft up. There's 1% less lift, actually, for every 3 degrees Celsius rise in air temperature. And we've recently analysed takeoff conditions and aircraft takeoff performance at 10 airports in Greece. And it turns out that the maximum takeoff mass of an A320 has actually decreased by about 4,000 kilograms over the past 30 years. So that's already happening and will continue into the future. And then finally, getting on to more hazardous weather, there's the distinct possibility of more lightning strikes as well. We know that lightning is related to temperature. There's more lightning in hot countries than cold ones. There's more lightning during the day than the night, more during summer than winter. So there's a clear link there. Heat is a crucial ingredient for the generation of lightning conditions. So it stands to reason that global warming, increasing temperatures will cause more lightning. And indeed, there is evidence to support that. A recent study calculated that there'll be 12% more lightning for every 1 degree Celsius of global warming. So that's just another potentially worsening hazard that aircraft will have to try even harder to avoid in the coming decades.
That's some sobering information. And John, again, we're already seeing how some of these changes are affecting aircraft.
Yeah, we talked about the jet stream earlier. And one of the things that we've already seen here at the command center is eastbound flights off the West Coast arriving before their expected times because they're getting carried along by a much stronger jet stream. And similarly, the flights coming in from Europe being delayed significantly. I'm talking about half hour to an hour longer than normal to get to places like JFK, Dulles, and even down into Miami, pushing into that headwind. He mentioned the heat, and one of the places where we see that, strangely enough, is Las Vegas. And even with the massive runways out there, if the wind's blowing one direction coming out of the west, and that's the departure setup that they're on, they can delay flights because they've got people that are going to want to taxi over to the west side of the airport and depart east because they're carrying the absolute minimum amount of fuel legally available, and they need to depart east so that they don't have to go and turn around and come back to the east after departing west. There's lots of impacts that are starting to just slowly rear their ugly heads, and it's going to get worse before it gets better, it sounds like.
Just to reiterate some of the points from our discussion today, pilots, file your PIREPs to give ATC and other air crews the benefit of your observations while flying. Passengers, buckle up when seated, even if the ride is smooth as glass, because that really can change in an instant. And on a similar note, if your flight operations SOPs don't address turbulence and its potential effects, you should probably add in that information. Lastly, in addition to the resources mentioned today like aviationweather.gov, stay up to date on the condition of the NAS with NBAA Air Traffic Services at nbaa.org/ATS. And for information about these and other weather-related issues affecting business aviation, visit nbaa.org/weather. And that's the latest from the National Business Aviation Association. Remember, you can subscribe to all Flight Plan episodes at Apple Podcasts, Google Podcasts, and Spotify, or wherever you find your favorite podcasts, including by asking your virtual assistant or connected device. Of course, you can also download Flight Plan directly from nbaa.org. I'm Rob Finfrock. Thanks for listening, and join us next time for a new episode of Flight Plan.